Yo, oh yeah, we're live. Yeah, I knew that. Yeah. So, I guess we'll chill around. Do some linear polynomial regression. Via pseudoinverse. Yada yada yada. Yeah. So let's just make a new. Whoa, this is getting rather filled. Let's just quick commit this so we just get some commits. Commits. Yep. Simplex method. Just commit this. There we go. We committed it. Sync the changes up. And then now let's create a new file called part4. So actually, let's just rename all these to be more accurate. So part2, rename this as well. Okay, cool. So now we have this nice new part4 folder. So let's just add linear polynomial regression, multiple linear regression by pseudo inverse as a file name. So let's just do not what we meant to do. Oh yeah, yeah. So if you guys want, I could link the code on GitHub. If you guys want to like go through it, but I mean, there's not really anyone here, so uh, okay, let's start reading. Okay, what? I don't understand why this is happening. Like if I open a file, so let's do hi. Okay, it's working. I don't know why. Oh, maybe it's because it's like I don't know. I don't know. So let's just do, I don't know, let's just name it startup. Okay, supervised learning, fitting functions to data sets, inputs and outputs, predicts the outputs, computers to predict outputs. Easy. Linear relationship between input and output. Okay, so this is our data, and we need to think about us basically trying to find a line y equals mx plus b, uh, such that, okay, so we can, and one way to do this would be, as he says here, you plug in each point, and you get this sort of system. That's a 3 by 2 times 1 by, wait, 2 by 1, so that would, yeah, that would basically be that. So you do that, and then, but that's a non-square matrix. Only square matrices can be inverted. Pseudo-inverse, before inverting the coefficient, we multiply both sides of the equation by the transpose. So the transpose of the coefficient matrix. So you multiply by 2 by 3, where it's like this column becomes the row, and this column becomes the row, right? So that it becomes square. You can take the inverse, and then you can basically solve for m and b. Number of parameters in the model we want to fit. Pseudo-inverse is defined by x transpose by both sides. Let's just go back here, just review it one more time. So 153 is here. Coefficient matrix 0, 2, 4, 1, 1, 1 is going to be here. And then it's just the parameters that we're trying to tune, M and V, are going to be vertical like this. And then we multiply both sides by transpose of this matrix. And then we take the inverse of that matrix. Okay, we sort of understand, I think. Okay, let's do this first though. Let's basically bring our matrix class over here, copy it. We have our data, and now we have to fit. What? I don't know. Anyway, we have our data, and we have to try to fit this now. So one way to do this is going to be so def pseudo-inverse. And here, well, it'd probably be better to just make one method. Let's start with the basic one, right? So we're given in our data, right? And now we can do get an import. So let's add from matrix import matrix. Wonderful. And then so we're passing in the data here. First thing we have to do, let's just go through it again. Just walk through it step by step. We'll figure it out. Okay. Boom. So first of all, we need to set it up like this. Rewrite it using matrix notation, right? So y equals mx plus b. So we need to create a matrix. For I in data. Basically, this is the what's the notation we're going to be using for this? Yeah. Now we need to turn it into a list, and then we need to do I dot 0. And then we basically let's just print y for now. And then let's just for debugging purposes, print, pseudo inverse data. Is it tripping? What? What? Oh, why did I put self? It's just in a class. I'm kind of tripping here. Yeah, okay, 1, 3, 4, right? And then first of all, we need to say y matrix. Um, y. Okay, cool. Now we need to make a second matrix. This is going to be the x matrix. This is the coefficient matrix, right? Uh, and so for example, 0, 2, 4, 1, 5, 3 is not going to be correct. So for this, it's going to be so this is going to be x. X equals, we'll create that list. Um, okay. Uh, in data, append, what we're going to append is going to be, we're going to append a list as such. So we're going to have I dot 1, comma 1. And then x matrix equals matrix dot x. And then we need finally the p matrix, which since we're assuming it's linear, it's going to be so let's just create m equals none. M equals none, and then b equals none. And we're creating a 2 by 2 matrix, so p is equal to m comma b. P matrix equals matrix dot p. All right. Okay, cool. So this is a start. I think it's a pretty decent start. Oh, it should be B matrix. That makes a lot of sense. Okay, cool. So we have the basic matrices, right? Now, if we look at the end result, right, here, we're solving for P. So we'd normally want to set up equations such that, like this, y equals kp, y equals xp, right? And inverse both sides, multiply. We normally just want to multiply both sides by the inverse of x. But instead, we can't do that. So what we're going to do is, we can do the pseudo-inverse. So we have here y equals xp, right? Same as we have here. Multiply both sides by the transpose, and then we multiply, we inverse this, and we multiply both sides. This will become the identity matrix, so it basically just becomes 1. We basically can ignore it. So now we know how we find p. Uh, Actually, we don't even need this whole p matrix thing, because we can basically say p equals basically x matrix dot matrix multiply. And now we need to give another matrix, right? Matrix multiply. We need to give another matrix, if I remember correctly. Right? So what we can do now is we can matrix multiply it by its own transpose. And then we need to inverse that. So we do x matrix dot transpose. And then once we transpose that, so currently we're just multiplying, we're taking the matrix, we're matrix multiplying, we're first transposing a matrix, we're multiplying that matrix by the x matrix, and now we need to actually inverse this. So dot inverse, and this will return another matrix. Right. And now we found the inverse of this, and now we need to basically just do dot multiply again. Sorry, matrix multiply. And what do we multiply by? We need to multiply by the transpose of x matrix. Matrix multiply times y. Oh, yeah, that's very nice of it to try to format this for us. And oh, so we need to transpose it first also. So now let's do p.show. So let's now do pseudo-inverse. Let's call it on our actual data. So data. Okay, so let's call it on our actual data. And okay. We should clean this up. Instead of doing this in one step, we could clean this up. So first of all, let's find the transpose, right? So now we can do, instead of doing this, we can do x transpose. And now, we could, um, so let's create x transpose first. And x transpose x is equal to x transpose dot matrix multiply with x matrix. What do we do x dot show? Oh, oops. I might switch my math wrong. I switched these. Okay, this makes a lot more sense. So let's just check that out. Cool. Okay, so now that we've got this, so now we have x transpose x. We multiply it by the x matrix. So now we need to inverse it. So x transpose x. Inverse. P x transpose x inverse dot matrix multiply with x transpose dot matrix multiply. What? That's right. Oh, Consmail show. Yeah. I fixed it. I fixed the code. Thank you, LM. Okay, first off, you don't know Marshall. Even worse. Goals. Base. But all people, I mean, like all people, yes. Yeah, I what? Oh wait. Oh, that was a bug. Should be solved now though, boys. Alright, boys. Remove the dot shows. Add a dot show here. Let's see what we get. Okay, I'm gonna just copy some ChatGPT code. To just 13401. Yeah, I just bought it. Pretty good. Pretty good. Pretty cool, eh? The data points are all at their points. We have a nice line. But I know one thing though. Instead of making this, we could basically just say, uh, I mean, there'll be like barely an improvement. Oops. Yeah, we figured this out. I understand how it works, but it's a little bit finicky still. Okay, cool. Yeah, we've been kind of being a bit lazy. Let's just, bro. Honestly, bro, I'm just gonna chill for now. Don't even feel like coding anymore. I don't feel like not coding. Okay, wait. Yeah, so we have to get good at this before we go any further. Okay, fine. Fine, we'll do this one. So change out the data and we'll fit. And instead of doing this whole thing, we'll just be uh I 0 for I in data. I in data. Okay, cool. And let's change out the data. Dude, they're using some like Unicode characters for negative signs, so it like gets messed up. Okay, cool. Oh, actually, instead of doing this, what we can do is we can do x data. We can do x data. The first thing of x data dot one minus 5 in the final value. We can do x data dot 0 -1 plus 5. Yeah, I feel like that's a pretty decent job. No, it doesn't really pass the trend though. Oh, okay. Okay, so there's actually a problem here. So, boom, bam, bop. Actually, we should go boom, bam, bop, and then put like a really high number, 500,000. Fine. Gonna be a little bit slow, but no, still a problem. Uh, um, wait, always do p dot show. No. Yeah. Okay, so how are we gonna debug this? There's definitely some type of error here. Because that does not fit the trend. Okay, so first thing we're gonna do is we're gonna go through this for we're doing pseudo inverse fitting for linear. So we're just gonna step by step debug, right? So first of all, let's check x of t. This is the transpose. Negative 2, 1, 3, 4, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Yeah, okay, that's right. It's gonna cause it to break out of the loop every time I do a dot show. Now let's see x of t, x transpose x, right? Let's check that and see what that equals. Whoa, 29, 6, and 4. What? There's some error there. Whoa, whoa, 29. Okay, so we'll quickly just do Okay, we'll just verify that so the first left thing is gonna be so this x value is gonna be it's a 2 by 4 times a 4 by 2. So what you have to do is you have to find the first row, first column. So -2 times. Okay, so it'll be -2 times -2. That'll be 4. 1 times 1, 5. 3 times 3 times 3, 9. 5 plus 9 is going to be 14. And then 4 times 4, 16. What? Okay, it's fine. So anyway, yeah, I think we did this right. Yeah, so boom. Uh, okay, so now inverse, right? We're taking the inverse of that. Um, am I doing this wrong, or is that an error in my plotting? Wait, -2? That shouldn't be a point. Is that a point? -2 comma 3, 1 comma 0. There's 4 points. Oh, okay. Wait. I think I didn't. Oh, wait. X of. Well, I'm doing all storage stuff wacky. Okay. Whoa. So the last element, right? That'll be. Oh, no. X data will be I of 0 for I in data. Wait, let's just have it print. I think that's why. So X data 0, comma X data -1. So -2 and 4. For now. Actually, now that I'm looking at it, I think should be like more vertical. Okay, so this is going to basically be our thing matrix, right? So anyway, the determinant's going to be AD minus BC, right? So 30 times 4 is going to be 120 minus 36, 84. 1 over 84. It's correct in that these should be decimals. Yeah, so this is all right. Right? So up till here it's right. So maybe now, yeah, so we're multiplying. This is going to be obviously a 2 by 2 matrix. So we multiply that by this. 0.5. 0.285. That's right. Well, I don't know what's up with this. Like every time I resize it, like it gets really hard to read. It's really unreadable. It goes from perfectly readable to very unreadable. Okay, it's fine. 142857 0.07. Yeah. Okay. Cool. So this is right too. So uh, wait. If you multiplied this is what a 2 by 4 matrix multiplied by 4 by 1 is gonna be a 2 by 1. So that makes sense. So okay. I'm really struggling to understand why it doesn't represent the data well. I think it's an error with the way I'm plotting. Uh, All right, bro. I'm